Hey there, welcome to today's coding walkthrough. Today we are going to solve a very popular problem in coding interviews, and that's implementing a randomized sets in C#. This problem is interesting because we need to ensure that each of our operation insert, remove and get random works in O1 time on average. Sounds tricky, right? Don't worry, I'll guide you through step by step and break down the code for you. Also, I'll share some personal insights on why this problem really tests your understanding of efficient data structure. Let's dive in. We are asked to build a class randomized set that supports three operations. Insert an element into the set if it's not already present. Remove an element if it exists. Get random, which returns a random element with equal probability. What makes this problem interesting is the O1 time complexity requirement for each operation. That means we can't use a simple list for all operations, because if an element exists or removing one would be too slow. So how do we achieve this? We need to make use of two data structures, a hash set or a dictionary for fast operations of O1, a list to store elements, which allows us to pick a random element in constant time. So here's the plan. We'll store the element in a list. We'll also maintain a dictionary to store the elements index in the list, which will help us with O1 removal. Now let's move to the code and implement this. Now let's break down the code line by line. Number 1, class initialization. Dictionary is used to quickly look up the array of any element in the list. List is where we store the elements themselves. This helps with random access in constant time. Here's a random number generator that we'll use for the getRandom method. Number 2, insert operation. We first check if the value already exists in the dictionary. If it does, we return false. Otherwise, we add the element to the list and update the dictionary with the elements index in the list. This makes the insertion operation O1. Number 3, remove operations. We first check if the element exists. If it doesn't, we return false. If it exists, we get its index from the dictionary. We then swap this element with the last element in the list, which allows us to remove the element in constant time by just popping the last element. Finally, we update the dictionary and remove the element from both the list and dictionary. Number 4, get random operation. We generate a random index between 0 and the last index of the list and return the corresponding element. Since accessing a list by index O1, this operation is also O1. Now let me share a quick personal insight here. When I first encountered this problem, my instinct was to use hash set alone. But it's not enough, because getRandom needs constant time access. This is where a combination of a dictionary really shines. It's a great reminder that combining data structure can often give you the power you need to meet specific time complexity requirements. And there you have a fully functional randomized set class that performs all operations in O1 on average. We learned how to use a list for quick random access, use a dictionary for fast lookup and updates, efficiently remove elements by swapping with the last element in the list. This is a common problem in coding interviews, and mastering it can really improve your understanding of data structures. If you have enjoyed this video walkthrough, give it a thumbs up and subscribe for more coding tutorials. That's it for today. Happy coding!